Hello, welcome back to another daily integral challenge. Today I'm going to take a look at the integral of square root of x times the square root of the quantity of x times the square root of x plus 1 dx from 0 to 4. This was actually part of the MIT integration bee from 2017, I think. And how I'm going to approach this problem is first I'm going to solve the indefinite form of this, and afterwards I'm just going to plug in the borders and calculate the thing. Alright, let's start the timer right here. Okay, so first I'm going to write down the indefinite form of the integral from above. So we're just gonna leave out the borders. Okay. With that done, I'm going to simplify the inner square root a little bit. As you might know, if you have a to the power of m times a to the power of n, that is equal to a to the power of m plus n. Also, something to note is if we have the square root of a, we can write that as a to the power of a half. So up here we have x to the power of 1 times x to the power of a half, and we just need to add up half plus 1, and we get the integral of the square root of x times the square root of x to the power of 3 halves plus 1 dx. Now, as you might have guessed, I'm going to do a little u substitution. I'm going to let u be equal to x to the power of 3 halves plus 1, which means our du is equal to the derivative of the one above. So we have 3 over 2 times x to x to 1 half dx. Okay, if we solve this for our dx, we get 2 over 3 times 1 over the square root of x du. Okay, let's plug it in, and we end up with, let's put the 2 over 3 right into the front, times the integral of the square root of x times the square root of u times 1 over the square root of x du. Now we can see the square root of x and 1 over the square root of x cancel each other out. We end up with 2 over 3 times the integral of the square root of u du, and this is simply 2 over 3 times 2 over 3 times u to the power of 3 halves. Now we're going to do a little we're gonna do a resubstitution, and we end up with 4 over 9 times x to the power of 3 halves plus 1 over, not over, but to the power of 3 halves. Okay, so this is our solution for the integral up above. Let's put that in. Let me add a plus c. It will be unnecessary up here though. So we have 4 over 9 times x to the power of 3 halves plus 1 to the power of 3 halves from the borders of 0 to 4. So now we have to calculate what that entire thing is, if we plug in 4 or if we plug in 0. So in the MIT integration bee you don't have a calculator, so now we're gonna have to do this by hand, which means we're gonna have to calculate we're gonna have to calculate 4 over 9 times 4 to the power of 3 halves plus 1 to the power of 3 halves. Okay, so what's this? 4 to the power of 3 halves, that's our problem here, is equal to the square root of 4 to the power of 3. Now, what is 4 to the power of 3? 4 to the power of 2 is 16. 16 times 4 is 64. So, what we're going to end up with is the square root of 64, which is equal to 8. Plus minus 8 usually, but we're going to assume it's positive 8. So, we have 4 over 9 times 8 plus 1 to the power of 3 halves, which is equal to 4 over 9 times 9 to the power of 3 halves. Okay, so what is 9 to the power of 3 halves? 9, we can again rewrite it as the square root of 9 to the power of 3. 9 to the power of 3 is equal to something big. However, what I'm just going to do is I'm going to cancel out a little bit here. I'm going to cancel out a 9 here and the 3 here, and I'm going to add a 1 up there. So all we have is 4 times the square root of 9, which is equal to 12. Okay, that was basically the hard part. Now the only thing we're going to have to do is subtract what we get when we plug in 0. So let's plug in 0. Let me pull a new border down here, because that will take less space. Alright. So, let's do it. We have 4 over 9 times 0 plus 1 is just 1, and 1 to the power of 3 halves is also 1, so we have 4 over 9 times 1, which is equal to 4 over 9. Alright, so now we know this integral is equal to 12 minus 4 over 9. That was already the hard part. Now we just have to know what 12 over 9 is. 12 is in terms of 9. Whoop. So we have to calculate 12 times 9, which is 112 over, not 112, 108. 108 over 9. Okay, so we just need to subtract 4 from that, and we get 104 over the power of over 9. That's it. So this is our solution. And let's stop the timer. Okay, that was the first definite integral we did on the channel. I hope you enjoyed this little one, and I'll see you in the next one.